let's see. Did you get that email that I sent you showing you a link to how you can see your recordings?
I haven't looked at it, but after this, I'll look at it.
Okay. Yeah, just to make sure that you can access that link. You may not have any need to review the sessions at this level that we're going over, since we're just kind of reviewing your pre-algebra. All right. Let's see if I can find some other interesting pre-algebra stuff for you. Do you know how to factor a number?
I think so, but I just forgot what it meant.
Okay, let's factor 80. Let's find all of the factors of 80. How would we begin? I have kind of an interesting technique that I use. I don't know if it's what they teach in school, but start with 80 and 1. Those two numbers multiply to 80.
And 40 and 2.
Yep. Then
20 and 4.
And then
10 and 8.
And then
5 and 20. No.
Okay, notice what we're doing. We're cutting the left column in half and we're doubling the right column.
16.
There you go. And I think that's all of them. And that's if you have a number that you can cut in half constantly. Sometimes you have a number like, well, let's look at the factors of 75. 75 and 1. Now, I can't cut 75 in half and double 1. So what else can I do?
You can do it to 5.
Right, I can divide it by 5 and make that go up by a factor of 5. So whatever you're doing on the left column, you're doing the opposite on the right column. And it can be halves, thirds. What can I do now?
5? No, you just did 5. I don't know.
Well, I could cut this in a third again and triple this. What can I do now? In other words, somehow, how do I get 25 and 3? I can increase this one by a factor of 3. Hold on, excuse me. I'm looking for 25 and 3. How do I get it from this technique? Oh, I could take that up by a factor of 5. That's what I meant to say. Which means I have to take this down by a factor of 5. And I get that. It's a little tricky sometimes. Probably where we went wrong here, we made it difficult to find that last factor because what we probably should have done as the first step was take this down by a third. Take it down by 1/3, take that up by 3, and now I can take this down by a factor of 5 and take that up by a factor of 5 and so forth and so on. So usually make the smallest cut you can. In other words, if I can cut that in half, do so. If I can cut it in a third, do that. Don't jump straight to a 1/5. All right. Let's see. What is this number? What's that equal to? Jenna, you still there? I lost the audio. I lost the audio. Huh. Okay, let's hang up and I'll call you back. Okay, bye-bye.
Okay, that's good.
Okay, yeah, I have to do it that way because I use Google Phone to call you. And then I can keep speaking through my microphone, and I don't have to use my speaker phone on my other phone, which isn't as good. So let's see, I don't know how much you heard. What's the answer to that?
A half? Or no?
No. Squaring means 1/4 times 1/4. How do you multiply fractions?
1/8. 1/16.
1/16. Now, what about the minus sign?
Since there's two of them, it's just a positive?
No. It's important to recognize that this 2 does not operate on that negative sign. In other words, it only operates on what's inside the parentheses. So this is not the same. Yeah, this is a different answer. If I write it like this, that's equal to 1/16. But this one up here is equal to minus 1/16. So where the parentheses are makes all the difference in the world. Okay? It's the same as if I have 2x squared, that's 2 times x squared. If I want to square the 2, I have to write it like this. Okay. What is absolute value? Have you had absolute value?
I think so.
What is this?
Would you first change the 1/4 to the 1/16?
Yep. So it's the same as this. But what's the absolute value of negative 1/16?
1/16.
Yeah. In other words, absolute value merely means the positive result. Ignore any negative signs. All right. Some of this stuff you may have learned, some you may not have. Which of the following numbers is divisible by 3? It's a little bit of number theory. I'm not sure at what grade level they teach it. They don't tend to teach it in high school, but then they expect you to know it in college. So without using a calculator, what is needed for a number to be divisible by 3? Has to do with the sum of the digits. They have to add to a number that is divisible by 3. In other words, that adds to 7, right? So that's not divisible by 3. This adds to 15, so it is. This adds to 19, so it is not. And this adds to 8, so it is not. A number is divisible by 4. Tell me which of these. To be divisible by 4, the last 2 digits have to be divisible by 4. So this one is not because 26 is not. This one is because 24 is. This one is not because 42 is not. And this one is not because 98 is not. All right. Prime numbers. Have you learned much about prime numbers?
A little bit.
What are the first 5 prime numbers after 50?
I don't know.
Well, let's go through them. Is 51 prime?
Yes.
Yeah, there's no factors of 51 other than 51 and 1. Well, and we know
53.
Right. In other words, we know that no even number is going to be prime once you get belong 2. 2 is actually prime, but it's the only even number that's prime. So we can ignore even numbers. 53, nothing divides into that.
57.
57 adds to what? What's 5 and 7 add to?
13. And 12.
12, and 12 is divisible by 3, so 57 must be divisible by 3.
59.
That's prime.
61.
That's prime.
63.
63 adds to what?
9.
So it's divisible by 3 and by 9. In other words, if digits add to 9 precisely, then it's divisible by 9. So 63 is not prime.
67.
That's the next one. Yeah. All right. Skipping around here. Tell me which of these is odd. First of all, odd times even is even. Even times even is even. The only thing that is odd times odd. Okay, so most products are going to be even. So tell me what this is. Only tell me whether it's odd or even.
Even.
Good. How many odd integers are between that and that?
Like 13 over 3?
No, 10 over 3 is, well, let's convert these to proper fractions. That's a good starting spot. In other words, we're looking for the whole odd numbers between these two numbers. Well, what's this number equal to? 10/3?
3 and 1/3.
Okay, and what's the other one equal to? You can use your calculator for this, but you actually should be able to do this without your calculator. What's 3 goes into 6 2 times, so it's got to be 20 and 2/3. Now, let's just list the odd numbers that are between them. That's the first one. 7, 9, 11, 13, 15, 17, and 19. So there's 1, 2, 3, 4, 5, 6, 7, 8 odd numbers between them. What's the greatest integer that divides evenly into both of those? And here's your choices. This is
6.
a multiple.
No. 9. Okay.
What's the greatest one that divides into both of them evenly? In other words, I'm pulling this from a multiple choice test, and here's your choices over there. So, to figure it out, where are you going to start?
36.
Hold on. Here's your choices. When they want the greatest one, why don't we start at the top? That makes more sense because 6 might divide into 36 and it might divide into 54, but that doesn't tell us anything about the others. If we start from the top down, does 27 go into 36?
No.
Does 18?
Yeah.
Does 18 go into 54?
Yeah.
That's it then. Okay. A little bit more about I'm not sure that you're going to need that for algebra. Hold on. This actually is a very good book to prepare one. All right, let's talk about averages. What's the average between these three numbers? No, hold on. How do you find average, the arithmetic mean?
I'll add them and then divide by 3.
Okay. So 18 divided by 3 is 6. Okay. What's the average between 1/2 and 1/4?
That's 3/8.
Good.
Right?
Yeah.
And then divide by 2. I don't know that.
Well, no, hold on. Let's see. This is 2/4. So it's 3/4 was what I got when I added them together. Now if I divide by 2, what's that number?
2/1.
Well, what's this number here? Sorry, I didn't word it very well. What's 3/4 divided by 2? Okay, let's make sure you know how to do these things. These kind of stuff is definitely critical for you to succeed in algebra. Remember what we can do when we divide by either a whole number or a fraction. There's a presumed 1 under that, right?
Mm-hmm.
So how do we divide a fraction by a fraction?
Flip it and make it multiplication problem.
Okay. What's that equal to?
3/4.
Mm-hmm.
No, 3/8.
All right. That was actually your first answer, 3/8. But I think you got it by a little bit of, notice that I can write 1/2 as 4/8, and I can write 1/4 as 2/8. So there's my 1/2 and my 1/4, and I can see that the average is going to be 3/8. So there's actually almost an easier way to do it, but I'm not sure there's anything much easier than just adding them together and dividing by 2. But this problem right here is easier for someone than this problem is. In other words, if I went to a ton of math students, most of them would know how to do that. but this would trip up a lot of people. And I'm not quite sure why. It's because we don't ever write the denominator to this. We don't ever write it like that. So you just have to know that the other way to do these problems is just to multiply this number by that number, and you have your answer. And it doesn't matter what this number is. In other words, if this number is 5, what is that answer? Janet, you still there?
Yeah,
Okay, you leave the top number the same, and the bottom number is just the product of these two.
20. Oh, that's it?
Yeah, in other words, it's the same thing. If I put the 1 under there, then it's the same thing as doing 3/4 times 1/5, right?
Mm-hmm.
So, if the 1's not there, just multiply that by that, and you have your answer.
Okay.
Okay. No, this is good. I'm glad I backed up, because it's not knowing this kind of stuff that gives people difficulty with algebra. It's not algebra.
Mm-hmm.
Well, here's an interesting one. 8, 11, 25. Hold on. I don't even know what that question is trying to get at. I'll go on to another one. The average of 6 numbers is 6. If 3 is subtracted from each of 4 of the numbers, what is the new average?
Just wait a minute.
What's that?
Sorry, my brother asked me a question. What was that?
Okay, here's a kind of a ACT type question. You have the average of 6 numbers is 6. Okay, so let's just say A plus B plus C plus D plus E divided by 6 plus F. We're saying that's equal to 6. Okay? We don't know what the 6 numbers are. We're just saying that the average of them is 6. And I can write that statement by that equation.
Mm-hmm.
Now, if 3 is subtracted from 4 of the numbers, what's the new average?
3.
We're not subtracting 3 from all 6 of the numbers. We're only subtracting 3 from 4 of the numbers. Let me tell you how to do average problems. Average problems are all about totals. In other words, I can take this statement here and multiply both sides by 6 so that I say that the total of those 6 numbers has to be 36. If their average is 6, then the total has to be 36. Okay? Now I'm going to subtract 3 from 4 of the numbers. So how much am I taking away from the total?
12.
So the new total has to be 24, right?
Mm-hmm.
Okay, so if I have A plus B plus C plus D plus E plus F, and it's divided by 6 and it's equal to 24, what's the new average?
4.
Correct. It's the sum of 5 consecutive even numbers whose average is 12. What's our first number going to be?
Is 5 numbers equal 12?
No. It's the average of 5 consecutive even numbers is equal to 12. In other words, I've got a bunch of even numbers in a row, and their average is 12. What are my 5 numbers? Go 2 to the left of 12 and 2 to the right of 12. That'll give you 5 numbers, and 12 will be right in the middle. And so it's the median, but it's also the average. In other words, 8 has to be the first number, 10 has to be the second number, 12 is the third, 14 is the fourth, and 16 is the fifth. Notice that I don't have to add these up and divide by 5 to see that 12 is the average. Right?
Okay.
Okay. So, and the question merely said, what is the sum of these numbers? And so we would, what is the sum of those numbers? Can you get it easily without adding them each up? If their average is 12, what's the sum?
Wait.
Remember what the definition is. If I divide that by 5 and it's equal to 12, then what's the sum of those numbers? That's the definition as to how I would figure out the average. I would add all 5 numbers up, divide by 5, and I get 12. Therefore, what's the sum of those 5 numbers?
12.
Solve this equation, get rid of the 5 in the denominator. Here, I drew this line a little funny. Let me do it like this. In other words, multiply both sides of this equation by 5. Totals.
12 times 5?
Yeah, totals are
50?
everything, yes. In other words, we didn't need to figure out what the 5 numbers were even. The question was, what is the sum of the 5 consecutive even numbers whose average is 12? Well, all I had to do is multiply 12 times 5 to know that. It's 60. But I didn't actually have to figure out the numbers. In other words, when you say the average of 5 things is 12, then the sum of those 5 things has to be 60, regardless of what they are. All right.
Okay.
Here's an interesting. The average of x plus 2 plus x plus 4 plus x plus 6 is 0. What is x?
-2, -4, -6.
X means there's only one value. There's one thing for x. It can't be multiple things. I mean, it can when you get into quadratics, but you won't be getting into quadratics for a while. In this case, x has to be only one thing. First of all, if the average is 0, what does it mean? These 3 terms have to add up to.
0.
Right, that's the only way it'll work. So, let's first remove the parentheses. In other words, I know that those have to add up to 0. That's the only way you can get a 0 average. X can be positive or negative, though. Okay, it doesn't have to be whole numbers. So, remove the parentheses. What do you get on the left?
What do you mean on the left?
On the left side of this equation, what you're always dealing with in algebra, and this will be our last problem, what you're always dealing with in algebra is an equation with a left side and a right side. Well, if I want to solve this equation, I first have to remove the parentheses. What do you get when you remove the parentheses? How many x's do you have?
3.
So I got 3x. How many numbers do you have?
3.
What do they add to?
12.
Okay, so there I've removed the parentheses. Okay. Now I have an equation I can solve quite easily. What's the first step?
Prove 3x.
No, get the number on the other side. In other words, at this point of the equation, we're going to gather all of our x's on one side, all of our numbers on another. So I'm going to subtract 12 from both sides. That leaves me with 3x equals minus 12. Now I want to get rid of the 3, which is currently multiplying x. So how do I get rid of the 3? Divide by 3. I couldn't quite hear what you said, but maybe you said that. So finally, we get x equals minus 4. That's the solution. Okay? All right.
Okay.
Jenna, are you finding this useful? Helpful?
Yes.
I think it will be, quite. I'm glad I backed up and didn't start straight with algebra, because you really do need to master some of these principles before you get into algebra. All right. All right. I will talk to you Monday morning.
Okay.
All right. Bye-bye.